Okay. Maybe we shall start. It's 2 minutes. So today we will focus on essentially two external speakers, which are Guillaume from Exane and Marco from Radicalbit. If we have 5 minutes left at the end, I also have some news, but they are not mandatory. They could wait for next month. And each presentation will last around 10 minutes. And you will have room for 5 minutes or more demos from each speaker if there are no or few questions, so that we take 40 minutes in total today. So maybe Guillaume, you can start. I think you already have shared the screen, so I leave the floor to you.
Okay, thank you, Ludon, and good morning to everyone. And thank you for having us to the second meetup of RosaeNLG. It's an honor to be with all you guys listening to our projects. So, agenda today, who we are, first of all. Exane BNP Paribas is an equity broker, mostly on equity European equities, listed equities. We have an execution platform which accesses exchanges, European exchanges, essentially. And we have a research product that is very well renowned. We are #1 in Europe as a research firm. We provide research to clients all over the world. Main language is English, as a matter of fact. And so we've been ranked first for a couple of years now, more than a couple, for 4 years, in Europe. And we have 250 analysts, sales, and sales traders. That's a quick overview. And in that, where do I stand? I'm a business analyst working on business intelligence and artificial intelligence projects for the research department, as a matter of fact. Okay, so the agenda, what our Rosae project goals were and are. Then I'll cover the functional ecosystem of the Exane BNP Paribas research tools. I'll give a slight overview of the technical architecture that we've put around the Rosae system. And then I'll cover the data that we use, the rules, and what the RosaeNLG system is able to produce. Then I'll show the final product, which is still under construction, as a matter of fact. And if I have time, I'll give you a few details on the next steps and potentially, eventually, a small demo of the calls to our servers. And then if there's room, questions and answers, we'll be happy to answer. So the project goals, first of all, well, we started this project 2 years ago, 2.5 years ago. The purpose was to produce automated comments of company data. So it's financial statements that we've built a database for. So we have large sets of data and we'd like to comment them. This is something that analysts do on a day-to-day basis. And we'd like to produce a more systematic approach to producing those comments. The other idea was to build a core knowledge base of the rules that underlie the comments. And this is probably the most tricky part, as you have to deal with experts in financial analysis. Well, they don't always like to give their rules, and they're not always very simple. But so it's a very interesting part of the project, and so the purpose is to provide working on those rules and apply them to a large set of industrial firms that we cover. And the third major point was to be able to produce those rules and then use a multilingual corpus of text to be able to produce those comments in French, English, and other European languages. So, well, we see it as a very promising project. The outputs are quite interesting. And so let's go into the process. So our ecosystem, very quickly, we have many tools. The Cube is what our clients can connect to. The Cube is most of all a web server that produces all the research that we provide to our clients. We provide textual research, we provide voice research, we provide videos, and we provide database accesses. So if I have time, I'll go through Cube very quickly at the end of the session. But basically, on the left-hand side, you have a picture of our portal. The second part is the Sake financial database. So that's the part in the middle. It's a snapshot from Cube because Cube shows the database. And typically here I put Airbus data on the screen. So a lot of financial data, financial statements data, and all the financial ratios that we provide on all the firms that we cover. And the last part is La Grille. So it's a matrix of, well, more than 1,200 financial indicators that we have for each firm. What's interesting is that we have this database on a very large number of years. So it's 800 US and European firms that we cover, over 30 years of data. So you can imagine that the matrix that we provide to our clients is very large. And it was worthwhile commenting the data that you see on the right-hand side of the grid. So the architecture that we use, we've packaged Rosé on a server by itself on the top side of the picture. So the JavaScript server is on the left-hand side. We have our Sake server on the bottom side, which holds the financial data. So we'll start from there, financial data from the bottom. And so we embedded that into a Python Death Note module that requests data from the Sake server, and we produce those data to the Pug rules on the Rosé server, and we generate the text for the Sake, which provides that same data to the Cube. So the data, what is the data? So you had a quick picture of the data, and eventually I'll show the grids afterwards, the La Grille, as they call it. So step by step, we access the data via APIs on our Sake server, load them into Python pandas, and then we calculate most of the financial ratios and other stuff that we use in our rules, like min-max, averages, medians, and things like that. So typically there you have a small code here in Python where we calculate the number of consecutive years where we have a negative information on, that can be on many indicators like the return on capital employed, or the capital increase, or the earning before interest and tax, and things like that. So we calculate many things directly in Python, and then once all those data are ready for use, we provide them to a JSON object that we feed into the Rosé engine, and we mix with the Pug file. So the next part that I will show are the rules. So I won't show all the rules because there are hundreds of them, but step by step. So we expressed the rules with our analyst in pseudocode, like typically if the number of years of free cash flow, FCF is free cash flow, is greater than 80%, and that last year's free cash flow was lower than 0, was negative, and that the first estimated year of free cash flow, so that's next year, is greater than 0, then right, despite having increased the past, and ta-da-da. So that's the typical type of rules that we have. Then we have the Pug file that shows how we use that rule, how it's implemented. So you can see that the greater than 80% is in there, that the negative years are in there also. And so it's a number of ifs that are piled in together. And so we have in that, we have the specific line where we say, despite having regularly increased or decreased in the past, and such and such. And you can see that we use the synonyms. I've shown a synonym expression just below, and we inject the data also from the data frames that you can see in the stock first estimated year. I think I'm still in time. Okay. So the output is batched, and we produce batches of files because as we cover 800 files, we'd like to have them ready in the morning just to check. So the XML files, this is typically an XML file that you can see at the top. We have the valuation paragraph and the growth and returns paragraph. And below, we have the example of the same thing accessible through an API that I will try to demo just afterwards. So it's the same kind of text. We have three parts of text here: the financial financial information, the financial structure, sorry, growth and returns, and the valuation. And the final product. So this is the picture of the final product. It's a web page. It's also a PDF document in which we embed the comments that you can see on the top right side with the exact same text, and the grid, part of the grid that we provide to our customers. So I'll try to show you quickly a quick demo if I have time. Ludon, you let me know for you play the timekeeper role.
You have 4 minutes left, including questions.
Okay, so I'll go very quickly. I'll share quickly a small screen where I will run the demo. Here we go. Okay, so typically this is an access to the server, and all I have to do here is type the company code, which is our code, and the text comes out here. There we go. Okay, so this is the text for the company 338, which is ACO Group. Okay, so that's a very quick demo. Sorry, and well, I'm ready for questions if you have. Anyone? No questions?
I have just one short on the demo, the very fast demo that you just made. The text are generated, they're not generated real time. You use text that are previously rendered in a batch, or is it done real time?
No, this one was a real time one. This is a really real time. So I can use another code. Typically, I can use for Antofagasta 309.691, 309.691, 309.691, and this is a real-time output that will be shown. And so this gets the latest, the most up-to-date data from our analysts. So if they have changed an earnings ratio, if they have changed any part of the data in the data set this morning, this will reflect the real-time information. Okay.
And the data goes through Python for analysis, and then to RosaeNLG JavaScript server to produce the text.
Exactly. So most of the calculations, well, all the calculations are done in Python. Very easy to use, very easy to embed, and so Rosae is really there to mix the text with the data and to produce the rules. Most of the rules are written in the Pug file.
Okay. Thank you, Guillaume. Are there any other questions? Don't hesitate. We still have 2 minutes. I'm sorry to be the timekeeper.
Okay. If you want, I can give you a few details on where we're going.
Yes, please.
I'm sharing my screen again. Okay, so our future developments will include adding those comments into our Cube website. This is not done yet, but will be done pretty soon. This is part of our Q1 developments. We have a running French version to build because we have clients requesting that the same text in French. And well, we have to improve our comments. That's the main project is to continue working with the analyst. Now we're far away from replacing analysts, to be clear. So it's very systematic comments, but it will save them time. So that's very appreciable. And the last part is creating other use cases that we have around sales and sales marketing and analyst marketing, where we provide text to our clients directly in emails and SMSs and things like that. So that's the main topics that we'll cover afterwards. Okay, I'll stop sharing. And up to you, Ludon.
Thank you very much, Guillaume. Marco, maybe we can switch to your presentation if you are ready.
Okay. So I will share my screen. Oh, I have to allow macOS to share the screen. Sorry. I need to quit. And sorry, because otherwise Zoom will not share.
You quit and you come back?
Yes, sorry.
Okay. No problem. So while Marco leaves and comes back, I'm asking if anybody would be able to make such a presentation during the last meeting. I remember, Jean Gérard, that during the very first meeting, you proposed to potentially present what you actually work on. Do you think that it would be possible for you next month to present? Jean Gérard, we cannot hear you, but maybe we can discuss that later in the meeting. Hello, Marco. I see you are back. Can you share your screen?
Yes.
Yeah,
you see the screen?
Yeah, we see your PDF document.
Sorry. Okay. So, hello everyone. Thanks for the opportunity. Today I will present my master thesis project that is making a time series database smart, human and machine communication towards conversational analytics. This project was done at RadicalBit, that is an Italian deep tech company that is specialized in the development of products with event stream processing and artificial intelligence. Our main products are RNA, NSDB, and GoLive. RNA is a data ops and MLOps platform that is able to manage the data life cycle and also to integrate artificial intelligence algorithms. NSDB is an open source time series database that is optimized for streaming, and this is the database that we are going to make smart today. And then we have our last product, that is GoLive, that is an end-to-end live stream shopping platform that integrates also artificial intelligence for customer behavioral analytics. So the introduction, the objective of this project is to build an end-to-end system that is capable of understanding the human language using Alexa in order to query the database. And for this project NSDB, and also to provide a coherent response in natural language based on gathered data. So as we can see with this schema, starting from the left, we have Alexa. Then we go into a phase of natural language understanding in order to convert the user input that is in natural language to a query, and then the process backwards. So starting from the data retrieved by NSDB, we will generate the language and put as output to the user through Alexa. Before starting talking about the architecture, here is a simple schema of what the end-to-end system will do. So starting from a phrase in natural language, like find me the number of tweets since yesterday, we convert this phrase to a query that is compatible with the database that we are going to query. This query will produce a result, in this case, a count with a number. And with this number, this result, and with the structure of the query, as we can see with the colors, we can generate a sentence that is representing the data. So the architecture in, let's say, in abstract is like this. So we have Alexa, we have the NSDB natural language skill, that is the code that Alexa will run. And then we have a natural language lambda, that is the communication interface between all the pieces. And as we can see, we have the database on the right, and on the bottom, we have RosaeNLG. So the flow, as we can see with the numbers, is data comes from Alexa, it passes through the skill. So the skill is responsible to convert the language, the natural language, the sentence of the user into a query. And then the natural language lambda will forward the query to an SDB that will produce some data. And this data will go to RosaeNLG, that is responsible to create the natural language representation. And then we go backwards with the text generated to Alexa in order to let the speaker speak to the user and answer his question. This is the more in depth the architecture of the system. And as we can see, the architecture is divided completely into two separated parts that are that share the query as point of communication. So the human to machine part is responsible to convert the human language to the machine language, for instance, the query. And the machine to human part, starting from the query, can convert the query into natural language. As we can see in right, we have a virtual machine that is running RosaeNLG with other containers and scripts that are useful to run the whole architecture, especially for Alexa, for helping Alexa understand better the language. And so it's the same. So starting from the left, we have the language, then we go right, and we have also the language, the representation of data, and then we return back to Alexa. So what are the advantages of this architecture, the modular architecture? Well, we can change the way we do natural language understanding. So instead of Alexa, we can use Google Home, Siri, or chatbot, or whatever. This time we will not change the natural language generation system. And we can change the database. So instead of NSDB, we can put MySQL, Postgres, or whatever with a little effort. And we can also change or add languages. Right now, the system is in English, but we can easily add Italian, French, German, or whatever languages are supported by the natural language understanding system and the natural language generation system. And the thing that is made that we can have because of the modular architecture is that we can also use these two parts separately. So we can perform standard query with natural language answer. So starting from the point of query, we have the SQL query and we have back natural language answers. Or we can use the human to machine part in order to have natural language queries, but with raw data and without the natural language generation part. But why we have choose to use RosaeNLG? Well, RosaeNLG, first of all, is open source and is very easy to use. Most important, no beforehand data is needed, and we we will see it later why is important, this thing. The other thing is reliable, and it offers a lot of tools specific for languages that allows us to have, for example, syntactic variation and no repetition in the language that we are going to generate. So what are the alternatives? Well, the alternatives, the cool alternatives are neural networks, especially recurrent neural networks or sequence-to-sequence neural networks that are cool for language generation, but they have two main problems for this kind of project. First one is that they are not reliable at all. And the second one, that is more big, is that they require a lot of data, and in this case, a lot of sentences to train the network. But the problem is that we don't have these sentences to train the network because we have to generate sentences based from data. And so RosaeNLG is the most easy way that we have to generate sentences without, let's say, having sentences to train as examples. We only have data. Speaking about templates, since the RosaeNLG is template based, we have different templates to handle different types of queries of the system. So we have metadata queries that are used to know which database, namespace, matrix, or dimension we have inside the instance of NSDB we are referring to, and so we will have template to describe these kind of things. Then we can have plain queries that are standard queries like count, and then can be plain queries. They can be temporal queries like the one that we have seen before, or also group by queries, and there is a template for that. And also we have special queries that we have added specifically for this project, that is a query that is triggered by one sentence in natural language, but is an aggregation of multiple queries, and these kind of queries are used to build a phrase that will describe the global view of the matrix. So not only one query, one response, but we have more queries in order to enrich the result. So here I have some little templates as example, these pieces of templates as example. For example, it's the code of templates is all divided into mixins that are piece of templates that combined will generate the entire phrase. So for example, here we have a mixin that is responsible to create a little piece of phrase that will represent the two dimensions. If we have two dimensions, we will explain the percentage of occurrence of this dimension. This template here is for distinct queries. So in order to explain the number of distinct value that we have in the database. And as we can see here, we will use also synonyms in order to explain the same things with in different manner in order to not be repetitive. And this one is another kind of template for an order by. So here when we retrieve data, we will explain to the user if the data that we are speaking to him are ordered in what way. And also here we can see that we have a lot of synonyms in order to not to be repetitive. In the last, here we have some end-to-end examples that are, these are screenshots from the Alexa console. And this is exactly the same thing as we can do with the real device. So on the left, we have a dialogue between Alexa and the user. The one on the right is the user and the left is Alexa. And then we can see that we have some request by the user, and Alexa will respond to the user with this sentence that is generated all by RosaeNLG. Then we have some additional where condition, let's say, and then it's performed another time the query, and we have the result spoken. On the right, we have the special metadata query in order to change, for example, the database that we want to query, And as we can see in the middle, we have the description of the namespaces that we have inside the instance of NSDB. And this is also this generated by RosaeNLG. On the left here, we have the special query. As you can see, is one request by the user, but the response is very complex because we have the number of, for example, in this case, the plan in the database, the number of occurrences, the percentage of the two occurrences, and also we can perform another query that will give us the result in the last 24 hours. And so this, with one single request, we will have an overview of the database, of the metric of the database. Here on the right, we have a group by query. And as you can see here, we will have the request, the response, and then we add an additional where condition that is additional where that will perform another query, and then RosaeNLG will generate another piece of phrases. This is all in real time, and this is a real conversation that can be done also with the real Alexa device. So for me, it's all. Thank you. And if you have questions, feel free to ask. Thank you.
Any question? I actually have one question, which is not about the natural language generation part, which I know well, but more about the natural language understanding part, which is done using Amazon. If I remember well, when you develop skills with Alexa, I remember that you have two ways to develop it. Let's say one easy way, but where there are quite a lot of limitations, and one harder way where you can do about anything you want. Do you know which way you develop the skill for the natural language understanding part?
I have used the standard. I don't know that if there are two different kind of skills. I've used the standard one with the interaction model. That is, yes, it's quite limited. For example, about the real problem is the fact that we need to provide examples in of the words that Alexa should understand. Right now, one here, I've done this 1 year ago, and now Alexa has developed a bit, and so it's a little bit better. But with these two things that we have here, so understanding script and dynamic API, we have built a system to, let's say, do a workaround and put and have Alexa understanding better the language, because the biggest problem was that with the real device, Alexa sometimes will not understand the words that are not real. For example, if we have I have here an example of the database name can be not really a real English word like event sim. And so we have built this script here that is running that help Alexa to understand these strange words. So the main problem of this project was the human-to-machine part and not the machine-to-human part.
Okay. Just one comment on the architecture. There is a Lambda version of RosaeNLG, which means that you can run directly RosaeNLG within Lambda functions. So it's one of the available packaging.
Yes, but when I've started, it was only with the Docker version, and so we go for that. But I see that is the Lambda version of it. if there aren't any questions.
Any other question?
Pass to you.
Okay, I'll take the screen sharing back.
Okay, thank you very much.
Thank you very much, Marco. Is there anybody who would be eager to present something during the next meeting next month? I remember Jean Gérard that you last time that you you are willing to share something. Is it still the case?
Why not? I need to think about.
Okay, we can discuss that later on. If there's anything, is there something to share next month? Maybe if it's too early, we'll present something else. Okay, if anyone else wants to is willing to share something, please tell me. A few quick other news, three very small things before ending the meeting. There's one news about the product itself, that is a development in the Java version of RosaeNLG, and which is the ability to put the templates, the PUG files, directly in as standard resources. So here the idea is to be able to build a jar that will contain both your Java programs, the RosaeNLG library, and the PUG templates. Prior to that, it was more difficult, and you had to put the PUG file somewhere in the file system. So a user told me that, and it's easier to build a jar that directly contains the PUG files. So it only concerns the Java version of RosaeNLG and not the JavaScript version. I go through that quite quickly. Yeah, there are some news about the contacts with the LF AI and Data Foundation. They have created a new stage. So previously there were only two stages, which were incubation and graduation. So graduation is, let's say, the last step, which is for very mature projects, open source projects with a very large user base. Incubation was still for projects that were, let's say, quite large with many users, which RosaeNLG would not would not fit that well in that incubation category. And they have recently, I think it was last week, created a new category which is called Sandbox. And the idea is to incubate the projects in this category before they can ask for incubation or graduation. Which are projects which are more early stage, like RosaeNLG, and maybe or probably during the next months I will ask the LFAI Foundation to accept this project as a sandbox category. The main impact, if it is accepted, which is not sure at all, is that it will give more visibility on the development of the project. So this is the date of the next meetup. So it's Thursday, 4th of March. So 4th as today, but in the early evening at 6 in the evening. Are there any specific points you wanted to discuss or to mention, or maybe some feedback about this new format where external speakers have more room, let's say, than during the first meeting? Any comment? Okay. So if there are no more questions or things to discuss, I'll close the meeting. Thanks again, Guillaume and Marco, for presenting what you have achieved.
You're welcome.
Thank you. And see us next month. In the meantime, if you are willing to present something, or if there are specific points you want me to present within the meetup, just tell me.
Thank you so much.
Thank you very much.
Thank you.
Thank you.
Have a nice day.
Bye bye.
Bye bye.
Bye.
Merci, au revoir.
Merci.